Up next, we have Zan Armstrong presenting Beyond Explore and Explain Diagnostic Charts in the Question Dimension. Here's a bit about our speaker. Zan is a data visualization consultant who focuses on creating charts for analysis, discovery, and decision-making. Zan's charts have been used by Google Research's scientists and ML experts, Tailscale, Scientific American, National Geographic, SF MoMA, and the SCAN project tracking COVID and other pathogens in wastewater, the White House, and the Dalai Lama. So many, many places. Let's give Zan a warm welcome.
Hello. Okay. Thank you so much for having me here today. Okay, I don't have to project, I have a microphone. Thank you so much for having me here today. I'm really excited to take you beyond the explore, explain paradigm, introduce diagnostic charts, and share the question dimension. But what's the point of this theoretic framework? To make more useful charts, to notice the important stuff. And behind the scenes, this is a place where our work can be really valuable and we're not doing enough of it. So we can grow our work in our industry, in our space. So let's look at that data analysis paradigm. Oversimplifying things, we collect and analyze data, find something interesting, tell people, celebrate. And usually it's right here where we think about doing data visualization, at the very end. And I think we've done a really good job helping people understand that data viz is really important for storytelling. So much so that I think we've conflated data viz with storytelling. And these, of course, are explanatory charts, and they're super, super, super important. We're talking about them a lot at this conference. But somebody, us or somebody else, has been making charts the whole way along. And these charts require craft and intentionality as well. And of course, this is our traditional paradigm where you don't know the answer for exploratory charts, you do know the answer for explanatory, but I think we're missing something. Because often with exploratory charts, you really don't know the question either. And you're using that exploration process to ask questions, to notice things, to answer them, and this really, really iterative process. And I think you're often using that exploration to find the question. And there's a whole section in the middle for charts where you don't know the answer, but you actually know a lot about the question. You know about the domain, you know why this domain is important to you, you know why this data is important to you, you know why you're asking the question, you know the questions you're asking. You're doing this over and over. You're going to ask the same question over and over of the same type of data, but each time it's of different data. Maybe it's the weekly report to your revenue stakeholder. Maybe it's every time you run that scientific experiment, you want to make sure it worked. What were the results? Did the controls break? You might just want to check the weather. And these need a name so we can talk about them and do them well. And there could be other names, but I've been using the name diagnostic chart with myself and people that I've worked with when I'm working with data scientists and analysts as a way to talk about what these charts are. And some of the times and these are really, really valuable charts for doing data visualization, for investing in our craft, for two reasons. One, the people are going to use them over and over and over and over again. So making them better, we get to benefit from that a lot. Also, often, depending on the data and the situation, the chart can be the difference between noticing the important thing or completely overlooking it. And lastly, we have a lot of information at this point in time. We know a lot about what's important. And we can use that knowledge about what's important to design more useful charts, to be more opinionated because we have information. Sorry. And you might think this is just a dashboard. We have people in the audience that have written about the big book of dashboards. And I think that this is definitely related to dashboards. Often we create dashboards when we have diagnostic charts, when we're in this phase. But I think they're not exactly the same. So I want to kind of just acknowledge that yes, there's a huge overlap. But I think this framework is really, really useful both for making more effective dashboards and for making other types of moments where maybe we're not making a dashboard, but we are making a diagnostic chart when we're in this mode where we don't know the answer, but we do know a lot about the question. So that was a lot of theory. Let's dive into an example. This was some research being done with Google and Lumen, and their goal was to discover how to grow lots of algae in a lab, which might not sound that exciting, but it's not, if you can grow algae fast, you can do a lot of other good scientific things, like help with climate change and make new drugs and more. Their job, figure out how to grow a lot of algae. They had 17 tunable parameters that they could do for each one of these little boxes, and it is a separate experiment. This room is a batch of experiments going on, and in each of those little boxes, they can control the airflow, they can control the light levels, they can control all 17 of these things. That is billions of combinations. So they were using machine learning to help predict good combinations, actually doing the experiment of growing algae for 2 weeks. If you think your code compiles slowly, you are not waiting for algae to grow, and see what happened. And just to kind of connect the experiment to the chart, so each of these little boxes would have turned into one dot on their chart. Right now, we're just looking at 2 of those 17 parameters, pH and temperature. And the output is how well did the algae grow? Was it bad, purple? Was it great, yellow? And they wanted to know what are the best and worst conditions, pH and temperature, for growing algae. And they wanted to know for all 17, but let's just start with 2. So you're all good at data viz. What's the answer? Where are the best and worst points? And as you're looking at this, how effortful was that? Are you absolutely sure that you got it right? And are you ready to skim 300 charts like this and be that confident? And make sure that you don't miss anything important? My stakeholders, my collaborators weren't ready for that. They talked to me like, can we do something better? And I listened to them. The last talk was a great tee up for this talk. I listened and I asked a lot of questions. And I heard Drew saying, I care about the best and the worst. And I was like, you know what? There is nothing in this chart that actually maps to best and worst. We can change that. So we did. This chart, I believe we can skim and we can look at with more confidence. We know exactly where the best growing algae were, what pH and temperature combinations. And we know where the bad ones were. And we know that the better ones are mostly like the best, but there's some other ones too. So what did we do? Our question was about best and worst, so we made those concepts literally visible. And often my job feels very literal. Somebody tells me they care about best and worst, and I'm like, great. I'm going to make a chart that shows that. And how do you know if you're showing it? If you can talk about it and you can point to it. If you can say things like, oh, the experiments with the best growing algae are bright blue, or they're on the right. And we are losing information here, right? We went from a continuous, best practice chart with continuous Veritas color scale to making arbitrary decisions, somewhat arbitrary, informed, for where these cut points should be. But really, when we look back at that Veritas, do we really experience that in a continuous way? Or did you mentally have to map, okay, great is yellow, look for the yellow points. Bad is purple, look for the purple points. How many hues were you using? And who chose what those cut points should be? Nobody. So by making an intentional choice, it means we can use more powerful charting techniques like highlight colors and small multiples. And it means that we can make those choices transparent. And actually, in the course of the analysis, they did keep this color scheme throughout. This is from the paper they eventually published, but changed what the cut points should be as they realized what made more sense for their data and application. But they were able to use the process to ask a better question to refine their understanding because we made those decisions transparent. So some practicalities for how to make great diagnostic charts. As again, the last talk was a great tee-up. Ask about what's important and notice those specific words. Make sure something literally represents them that you can point to or describe, and if not, change your chart. Let's see this in another case, another example. In this case, I was working with the wastewater scan folks very early on. I started working with them in 2020 in December, and they're now part of the national CDC wastewater monitoring program. They can test sewage at wastewater treatment plants for RNA traces of diseases. If you are sick, you poop RNA from the thing that you are sick with, along with many other things. And that's really useful for understanding if a disease is present or absent or rising and falling in a community, and that can inform effective action. So in this chart, we can ask, is the amount of RNA, like we'd made these charts originally for COVID, then for COVID variants, then for other things, including Mpox, and which is a relative of smallpox. And you can see, it was originally designed for the question, like, is RNA decreasing or increasing? The amount of RNA, or the amount of kind of viral load in the community. But when a disease or pathogen is emerging in a community, or when it's going away, whether it's seasonal or something emerging, or we actually really, really care about another question. We care about, is it detected or not? And in a standard chart, the difference between was not detected being coded as 0 and a very, very little bit, those things are very, very, very close together. And applying a principle that I learned at InfoVis 2014 is that if data is meaningfully different, the chart should look noticeably different. And in this chart, yes, you can kind of see it partially due to what's happening with the max y-axis. And you can kind of, because there actually is a gap between like the minimum value that we can detect and what we're coding as 0. But it's still something you have to squint, and then you can't, it doesn't jump off the page. But it's really, really important. It should look noticeably different. And so by giving it its own baseline, its own mini chart with an aligned x-axis to the main chart, we could see those non-detects really well. But this isn't the only way to do that. And in fact, when Mpox was was an emerging challenge in the United States, when we first started to get cases, the scientist, Dr. Marlene Wolf, put it in a Google spreadsheet. She could make it, she could share it. Conditional formatting, she's got a chart. This is a very effective chart for her needs, for her to be able to see which, each row is a different sewage treatment plant, a different community, which rows has Mpox been detected in and which ones has it not, and where have they sampled. And this is not the only way to do it. They worked with, eventually started working with Stamen Design to build dashboards. I set them up with a bi-weekly newsletter. They've been sending updates every week or by 2 weeks. And now we can see for each disease, for each pathogen, can see a set of charts. These are the 8 charts for the Bay Area. So each row is a chart. Each set of charts is a different pathogen. On the top, those are both Mpox, and the bottom are both types of influenza, including one of those is the avian bird flu that we've been tracking. And immediately you can skim these. This is over a year of data and get a lot of information because we've been so focused on the question of presence versus absence. If you were trying to show these as like mini line charts and trying to ask the how much question at the same time as the present absent question, you wouldn't be able to make that distinguish. But by focusing the question, we're able to answer it in a really coherent way across a lot of data. And the exciting thing is this worked. Data plus local, state, and national public health work plus targeted vaccinations worked. I pulled this data last night from the CDC's website. There is no sewage treatment plant that we're testing in the country where Mpox is currently being detected. And it had been in almost every state, if not every state, 2 years ago. Some practical process for this, things like write down your questions. Make at least 1 chart per question. And consider those expected situations. If what's really, really important is the difference between presence and absence, that should look obviously different. You should be able to notice that. And going through this, you might discover, as the previous talk talked about, you may discover that you're actually asking a different question and come back to the top. So I want to talk a little bit in this next section about some of the kind of like questions that come up as I'm working with people to make diagnostic charts, especially in situations where the guidelines for making a diagnostic chart might be different than the best practices or guidelines at the communication stage. So one is, what if the question is vague? Like, did anything unusual happen this week? You might be able to refine that question, but it might be okay to keep it depending on if you can make usual visible in some way. So imagine kind of like a standard, typical business graphic where you want to know, like you have either daily, weekly, or monthly data, and you want to know how it's changing over time. This is number of page views for the Wikipedia page for Saturday Night Live in 2023. You might make one of these charts. You probably don't make the first one because it's too jagged. You probably don't make the second one because people don't like weeks for some reason. So you probably make the third one because everybody loves months, even though they have different numbers of days. And you had a lot of information. I talked about that in 2016 at OpenVisConf. And you might make this chart and be like, great, Saturday Night Live, and then you make another chart for Microsoft Excel page, like page views for the Wikipedia page on Microsoft Excel, and you look at these and you're like, you know what, those actually look kind of the same. Microsoft Excel, people's interest in Microsoft Excel and Saturday Night Live are basically the same. That makes sense. But maybe you actually want to look at that daily data. So you make this chart instead. Now we can see each point is a day, and we can see our 7-day moving average, and we can see a lot more of the texture of our data. And this data was in those previous charts, but because of the day-to-day comparisons, the lines, they were really distracting, they were hard to see. And it was hard to notice, for example, in the lower chart, the Microsoft Excel, we have that nice weekend, weekday seasonality. And we have summer dips in both of them, but the summer dip is much softer for Excel when people are going on vacation, maybe not doing as much business-related work. And maybe that last data point that we looked really concerning earlier is probably just the holidays. And we see a different shape in Saturday Night Live. And maybe if you're making this for NBC, and probably you have some internal data similar to this, you can also use the knowledge that you have of Saturday Night Live happens on Saturdays. And interestingly, the page views peak on Sundays. I'm not sure if that's a time zone thing. I tried to figure out for the Wikipedia data what time zone they are taking things in, and I couldn't figure it out yet. But maybe you can that 1 day a week is important, so you can color that and be like, oh, actually there were some spikes that weren't on that day. What's going on with those? You might also be able to put in the planned end of season. That's the thing that you know of when the season's supposed to end, and then know, at the time you would have also known this, that interest dipped because they stopped making shows because of the writer's strike. But you can use your domain knowledge to craft the graph. There's no way that your tool has this information. You have information. Use it. So if anything's unusual, you can enable pattern matching. You can have complex charts that have enough texture that you can notice, oh, Sundays tend to be our big days, but what about those other days? What's happening there? And a lot more of them happened later than earlier. That's interesting. You have enough data to be able to compare unusual to usual and have an answer to that. So what about accuracy? Truthful, we have folks in the audience who have written books about this. This example is not one that I worked on. I made the data after this event, kind of looking back. This is about the Texas energy crisis in February 2021. There was a huge winter storm, and they instituted rolling blackouts to save the grid. There were also price hikes because of how their energy grid is set up. And EIA has great data on energy use and energy forecasts. This is 2 months of data from before the crisis to when the rolling blackouts were instituted, and just showing this both with the forecast and actuals, and the second chart with the difference. So these charts work really, really well together. Often when we are interested in forecasts and actuals, we're also, the hidden question is what is the difference? And making that question explicit and looking at over-unders is great. So these charts work really, really well together. But you might notice that the difference looks different. This is the same data. The bottom line is just the difference between those top two lines, the orange and purple. But in the top graph, I see a big, chunky area with a big gap. And then I see an area with basically no gap as far as I can tell, maybe a little bit. It looks tiny. On the bottom chart, I see this kind of nicely decaying, slowly decreasing gap over a 2-week period. This is the same data. What's happening? Our perceived difference is not the actual difference. We perceived shortest line difference. We do not perceive vertical difference when we see the difference between two lines. And zooming into the area that we were just talking about, we're zoomed into that period right where the big gap appears. And even here, zoomed in, I can't force myself to see the vertical distances. I just see those lines overlapping because the daily seasonality is as big as the daily differences, as the differences between those two lines. And even if I draw them in, I can't see that soft decay that's actually happening until I give them their own baseline. You can't overcome our visual perception. You have to work with it. So by having a second chart that complements the first chart, we can see what's important to us directly. So by making charts, and I'm not the first one to talk about this. I missed the talks earlier. I'm embarrassed to admit because I was finishing my talk. But I understand this is not the first time we've seen this chart today. And now I know more about what's behind it. But Cleveland looked back at Playfair's chart in 1994 and pointed out that even in this chart, we missed something, that if you draw those differences, there's actually this huge section. And once you know to look for it, you can see that bump. You can imagine like, oh, actually, okay, it would have been small, and then it would have gotten big, and then it would have gotten small again, but I cannot make myself see it. If judging differences is important, you need to also show the difference. By designing for the question, we can actually be more accurate on what is most important to us. Make sure that the answers that are most important to us are also something that we perceive with the most accuracy. What if it's complex? What if it's too complex and they don't understand it? Or what if it's too boring and this chart is really boring and maybe I shouldn't have boring charts? Boring can be good. Going back to that MPOX. This is a wonderful boring chart. We basically don't have MPOX in the Bay Area for the last 6 months. I love this boring chart. I want more charts like this. It is boring and it gives us confidence. Yes, there was one day, maybe it was sampling error, maybe it just popped up once. This chart is complex and useless. I made this for some scientists I was working with. I was so excited. I was doing a shiny thing, and it totally didn't work. But fortunately, I was jet lagged, and I woke up in the middle of the night, and I designed this chart, and I sketched this chart, and then made it afterwards. It's 47 line charts. It's complex, but it was incredibly useful. It helped. Really helped with discovery that was later published about materials. You can also make charts that are complex and useful and beautiful, especially when you partner with people that are excellent at making things beautiful. This was from Stamen Design back in 2016. I worked on this project. It was a really amazing project to get to work on, and it showed up in SF MoMA as well. This was made for scientists. A lot of complexity here, a lot of intentional design that made it work. So complexity is good if useful. Somebody saying how that looks funny, that can be a huge success when the other option is they don't notice it at all. Boring can also be very useful if it gives you confidence and you can immediately understand that everything is good, you can move on and focus on something else that day. So I hope that you leave going with this new paradigm where we have the question dimension, we have diagnostic charts, and some ideas for how you can make these charts really effectively and use our craft. A lot of the same tools, but applied in slightly different ways earlier in the analysis process, in your own work and with your stakeholders. Because it's not enough for the important data to be visible. The question is, will you notice it?
Okay, I'm going to hand this one to you, so you're center stage. We do have a virtual question, so very exciting. The question is from Diane. How do you approach surveys with multiple questions? How do you pick which ones to highlight? Do you look at the meaning of each question or look at the numbers and choose the most impactful ones? Do you want to read it?
I think I can. Yeah. I almost never do survey data, so I don't have a great immediate answer. But I think my general answer is whether if it's your own domain, you can still have a conversation, tell somebody what's important, and ask them to write down the words they use, and make sure that whatever they're writing down, you make visible. And if you're doing it with a stakeholder, if it's their data, it kind of goes back to that last conversation of the last talk of have the conversation with them, try to figure out what's most important. When you're in the analysis phase, try to find a way that you can look at all of your data in detail, making effective like-to-like comparisons, making sure that your comparisons are meaningful. And as you move into the later stages, then the great thing with explanatory charts is we have a huge advantage over diagnostic and exploratory because we know the answer and we can use that. So that's kind of those should be different than your diagnostic. Thank you for the question, Diane. I can repeat the question. If you just enunciate, I can repeat it into the mic.
I'm curious about dynamic titles and Mad Libs kinds of setups for a diagnostic chart to auto-generate the insight. I noticed that you didn't have anything like that in the diagnostic examples you shared.
So you said, I'm curious about automated titles and Mad Lib style titles that are automatically generated. Do you mean more like that are those coming in response to an interaction, or are those coming kind of based on like the system recognizing what's important and helping the person see it? The latter. I think that's a good question. I think that's an interesting place for how we can kind of partner with our automated tools. And I think there's a lot of really interesting potential for how we can partner with AI and automation to help us get the best chance to do pattern matching. I still think our brains are really powerful and to have that chance, but I could definitely imagine, maybe not for the title, but for like, or maybe for the title, but also kind of helping point out things that are unusual. Like maybe if I hadn't colored the days on that, on the daily dots, if I hadn't noticed, maybe it would recommend, hey, like day of week is important. Let's make sure that that's visible in some way and make that visible for me. So I think there's interesting potential there. I haven't personally explored it. I think there's still a lot of low-hanging fruit in even just like static charts and spending more time looking. But I do think that that's that kind of not trying to give either the person or the automation all the responsibility, but finding the best ways to work together could be a really interesting area to explore.
Thank you. I think we have time for one more question. No more questions?
I think I can also say with part of the answer to the last question is that I'm often working with the people either like they're the analyst or the scientist themselves, so I'm helping them better see their own data and better make their own charts, or it's one step removed where like I'm making charts for an analyst or scientist who then will be using those with their team or their like with the public health officials. So often it's at the level of I haven't done as much in kind of terms of like building big tools and more at the level of like working with the individual, but I think that applying these techniques to the big tools makes a lot of sense.
All right, so our last question is from one of our virtual attendees, Louisa. Do you have examples where diagnostic charts served as a step to getting you towards an explanatory chart, or do they usually serve as a final artifact by themselves?
Great. I definitely have examples of where it's a step to the final chart, and have examples where it stood by itself, where what it did, like my single favorite chart that I ever made was never seen by more than like 3 people because it was made for part of an analysis process and part of scientific discovery, and by the time they got to writing the paper, the chart was really helpful for helping them discover what they needed to discover, but it wasn't the chart for communicating it. And we actually made some other really great charts for the communication part, but that my amazing grid of 64 pie charts combined with 8 mini grids never saw the light of day, but was really useful. So I think it's enough for the diagnostic chart to be useful in the process of analysis, in the process of helping generate new questions, in helping you have those that look funny moments. That's enough. That's like a chart that generates a good question is a successful chart. But plenty of times, where it's a stepping stone as well. A great example is many of you have probably seen Nadi Bremer and Mai's the When Babies Were Born. It's in her book. The previous chart I used in a conference talk. It was more analytic of like, hey, look, seasonality when babies are born. And then Scientific American invited me to write an article. I looped in Nadi and we did it together. Those 2 charts are very different from each other. They're like, something's interesting here. There's some big spikes chart versus like the communication chart were very different in terms of how they're designed and both were good charts for very different reasons.